Hello everyone. So in this video, we're going to discuss the concept of integration by substitution. So this one is an advanced technique in getting the antiderivative of functions. Okay, pero bago tayo mag-proceed dito sa concept na to, i-recall muna natin yung isang technique na itinuro sa inyo nung differential calculus, which is yung chain rule for differentiation. Now, the chain rule for differentiation is applicable kapag gusto natin kunin yung derivative ng isang function na pwede nating isipin as a composition of two functions. Okay, bakit natin gusto itong i-recall? Kasi pwede natin isipin na yung integration by substitution ay yung kabaliktaran na process nitong chain rule. Okay, so let me just present the formal definition of integration by substitution, or this is sometimes known as U substitution. So if we have three functions f, g, and capital F, wherein g prime of x is continuous over an interval, and small f is continuous over the values of g, at yung capital F natin ay antiderivative ng small f or capital F prime of x is equal to small f of x, then we have this integral. Okay? Now, kaya ito ay kabaliktaran ng chain rule kasi kung ibe-base natin sa chain rule, but this time palitan natin. So, if we want to get the derivative of capital F of g of x, if we apply the chain rule, this is f prime of g of x times g prime of x. However, we have mentioned or sinet natin na yung capital F ay antiderivative ng small f. Or yung f prime, capital F prime ay equal to small f. So this one is actually equal to f of g of x times g prime of x. So ibig sabihin, if we get the antiderivative of this one, that is the same as getting the antiderivative of this. Since we know that differentiation and anti-differentiation are inverse processes, kapag in-apply natin to, technically, matatanggal itong part na to. So we end up with f of g of x. Now perhaps we'll be able to understand this better by applying it in some integral problems. Okay, first example. We want to find the integral of x squared minus 3 times 2x dx. As mentioned previously, this is also referred to as U substitution kasi yun yung kadalasang variable na ginagamit natin wherein U, this one is a function of x. Okay? So, demonstrate ko muna paano ito ginagawa. So, we let U be equal to, in this case, x squared minus 3. Now, if we do this, what we do next is we get the derivative of U with respect to x. So, this is 2x dx. Okay, so what now? Note that with the representations that we used or the substitutions that we used, this part here, this is actually equal to U. Tapos itong part naman na to, this is actually equal to du. So yung integral problem natin, this one is U du. As I was mentioning before, kahit iba yung variable, basta pareha siya doon sa differential involved, mag-a-apply pa rin yung mga techniques natin sa pagkuha ng antiderivative. So this one, pwede tayo mag-power rule. So u squared over 2 plus c. Now, the last step, since ang ginamit or ang original variable natin sa problem is in terms of x, dapat sasagot natin in terms of x pa rin. So this will actually be x squared minus 3 squared over 2 plus c. Okay? So hopefully wala pang questions. Let us proceed with the next example. Okay, example number 2. The integral of x squared times x cubed plus 5 to the fourth dx. Now, it is normally the case na kung ano yung naka-raise to a power, yun yung gagamitin nating substitution. So, dito, we can let u be equal to x cubed plus 5. So, yung ating x cubed plus 5 to the fourth, that will be u to the fourth. Tapos, kopyahin ko muna to as x squared. Then, may dx tayo dito. Then, we get the derivative of u with respect to x. So, we get here 3x squared dx. Okay, this one involves an additional step kasi hindi katulad do sa previous example natin na directly masasubstitute natin yung value ng du. Dito, hindi kasi wala tayong 3x squared dx dun sa ating integral. So, how do we do that? Well, note na sa integral natin, let me just rewrite this. U to the fourth, then x squared dx. Sa integral natin, ang meron ay x squared dx. So, what we can do is from this part here, we can actually manipulate it para magkaroon tayo ng x squared dx sa isang side. We can do so by dividing everything by 3. If we divide everything by 3, we get d over 3 equal to x squared dx. Now, since napalitan na natin, or nagkaroon na tayo ng x squared dx dito, pwede na actually nating palitan itong x squared dx dito ng du over 3. Or this is 1/3 u to the fourth du. Then same ulit, power rule. This will give us u to the fifth power over 15 plus c, or x cubed plus 5 to the fifth power over 15 plus c. And this is our answer. Okay, now alternatively, ang pwede natin gawin is we can actually solve for dx here. So alternatively, dx here will be equal to du over 3x squared. Okay, so alternative method, from this part here, yung dx, papalitan natin kung ano man yung nakuha nating value na du over 3x squared in this case. So we have x squared, u to the fourth, du over 3x squared. So in this case, magka-cancel yung x squared, and then, babalik pa rin tayo sa part na ito. So same pa rin yung makukuha nating answer. Okay, let's proceed to the next example. Okay, ito naman, it involves trigonometric functions. Ay, before we proceed, before we make the substitution, sulat muna natin to as sine theta times cosine theta raised to negative 3 d theta. Ay, since nasulat na natin this way, mas obvious na yung substitution na pwede natin gawin. So, let u be equal to cosine theta. This would mean that du is negative sine theta d theta. Now, similar dun sa previous example, we can actually solve for d theta. So, d theta will be equal to du over negative sine theta. So, we have the integral ng sine theta times u raised to negative 3. And then d theta is du over negative sine theta. So, these will cancel out. Pero may matitirang negative. So, negative u raised to negative 3 du. Then, apply ulit ang power rule. So, this will give us 1 over 2 u raised to negative 2 plus c. Or 1/2 cosine theta raised to negative 2 plus c. Ayan, medyo pinaghahalo-halo na natin yung mga discussions natin before. Okay, this one in particular will require us to use integration by substitution twice. Okay? Yung first, so we can let u be equal to 2 theta. This would mean that du is equal to 2 d theta, or d theta is du over 2. I know using this first substitution, we end up with cosine squared u sine u times du over 2. So, labas na natin yung constant. So, 1/2 integral ng cosine squared u sine u du. However, hindi pa rin natin masosolve itong integral na to basta-basta. So, we make another substitution. So, nasa sa inyo na kung aling variable yung gagamitin nyo. So, since ang kasunod ng u sa alphabet ay v, yun na yung gagamitin ko. So, we let v be equal to cosine u. Okay? Na integral ng v squared sine u, and then we solve for the derivative of v with respect to u. This gives us negative sine u du. We solve for du. Du is equal to dv over negative sine u. So, papalitan lang natin yung du ng nakuha nating value na to. So, dv over negative sine u. So, these will cancel out. May matitirang negative. And then, ilabas natin yon, negative 1/2 integral ng v squared dv. Okay, and then just solve this simpler integral problem. This will give us negative v cubed over 6 plus c. However, yung original problem natin is in terms of theta. So, ibabalik natin yung mga substitutions na ginamit natin. Okay, recall that v is equal to cosine u. So, dito ko na lang isusulat. So, we have negative cosine u cubed over 3 plus c. However, u is equal to 2 theta. So, ang final answer natin is negative of cosine 2 theta cubed over 3 plus c. So, from a complicated integral problem, na-reduce natin siya by substitution, and then we reduced it again by another substitution. Okay? Now, it goes without saying that this is also applicable for definite integrals. So, for example, we have this one here. So, the definite integral from 2 to 5 ng x minus 4 to the third power dx. Now, technically, without substitution, masasolve pa rin natin to if we expand this power of binomial. Pero syempre, mas tedious yung process na yon. Okay? So, if we simply apply integration by substitution, so medyo obvious na that we let u be equal to x minus 4. This would mean that yung ating integral will be reduced to u cubed, and then du is equal to 1 times dx. So dx. I noticed that I did not intentionally write the limits of integration. Kasi maiiba yan dahil in terms of u na tayo. Oops, sorry, may error ako dito. This should be du, not dx. Okay? So as I was saying, I did not intentionally write the limits of integration kasi yan yung limits of integration kapag in terms of x tayo. Pero since this time in terms of u na tayo. Now, we have two options. Yung first option natin is kunin lang muna natin yung antiderivative nito. So, antiderivative nito is u to the fourth over 4. And then, we rewrite this in terms of x. So, x minus 4 to the fourth power over 4. Then, ibabalik na natin yung limits of integration. Then, we just apply FTC. So, 5 minus 4 to the fourth power over 4 minus 2 minus 4 to the fourth power over 4. This gives us 1/4 minus 16 over 4. So, minus 4. Negative 15 over 4. Okay, yung second possible way natin to do this is i-consider natin yung substitution na ginamit natin and yung limits of integration. Okay? Now, since we made u equal to x minus 4, we can actually solve for the values of u at the limits of integration. So, at 2 and at 5. Oops. Pangit ang pagkaka-encircle ko. So, at 5 and at 2. Okay? So, at x equals 5, this would mean that u is equal to 5 minus 4 or u is equal to 1. So, at x equals 2, this would mean that u is equal to 2 minus 4 or negative 2. So, ibig sabihin, yung ating definite integral will be transformed into the definite integral from negative 2 to 1 ng u cubed du. So we have u to the fourth over 4 evaluated from -2 to 1, which gives us 1/4 minus 4, so still -15 over 4. So either way, of course, since this is the same definite integral, we should arrive at the same answer. Okay, now for our last example for this video, let's consider this definite integral. The definite integral from 0 to 1 ng x over 1 square root of 1 plus x squared. Let's solve this using this substitution. So let u be equal to 1 plus x squared. This would mean that du is equal to 2x dx. Okay, moreover, yung ating integral or yung limits of integration natin. So at x equals 0, this will give us u equal to 1. And at x equals 1, this will give us u equals 2. Okay, so with this new definite integral, will become the definite integral from 1 to 2 ng x over square root of u dx. Okay, this will be x over square root of u, and then we solve for dx. Dx will give us du over 2x times du over 2x. Cancel. So we have the definite integral from 1 to 2 ng du over 2 square root of u, which we can now get as square root of u, evaluate from 1 to 2. Or we have square root of 2 minus 1. Okay, now alternatively, we can approach it this way. So let u be equal to square root of 1 plus x squared. Doing this, ang du natin will actually be equal to 2x over 2 square root of 1 plus x squared, or x over square root of 1 plus x squared dx. Now, ang kagandahan sa paggamit ng substitution na to is this is directly the integral that we want to get, no? So, ibig sabihin, itong entire thing na to is just du. So, meron lang tayong integral ng du, which is equal to u kapag itong substitution na to ang ginamit natin. Okay? So, this gives us 1 plus square root of 1 plus x squared. Evaluate from 0 to 1. The answer is still square root of 2 minus 1. Okay, so the point here is that there may be multiple substitutions that are possible to make dun sa isang definite or sa isang integral problem. So, depende na yun sa mapipili niyong substitution if it will be easier or not. Okay, so this ends our video discussion for integration by substitution.